Hey, hello everyone. We are live. Welcome to the MongoDB podcast live stream. My name is Ricardo Mello. I'm a developer advocate over here at MongoDB. I'm specialized in Java and Kotlin content, and I'm based in Brazil. Let me know where you're tuning in from in the chat. Tell us. They will be focused on two exciting topics, Spring and MongoDB. So feel free to share your questions in the chat, and we'll do our best to answer them during the stream, okay? We're joined today by two Spring experts, and I'm excited to introduce them. So first we have Christoph. He's a MongoDB champion and engineer on Spring Data team at Broadcom and lead for Spring Data MongoDB. And next we have Mark, a software engineer and Spring Data project lead at Broadcom with a strong focus on reactive infrastructure. Very good. In this live stream, we'll explore how Spring Data and MongoDB can improve developer efficiency. Mark will guide us through the basics of the Spring Data and repositories, while Chris will dive into MongoDB features like updates methods, applications, Spring Data with vector search. Very good also, okay? So yeah, how are you doing, guys? All good?
Oh, very good. So while you are based in Brazil, I'm based in Germany, and not too far away from me is Christoph. Well, a little bit to the south in Austria.
Chris from Austria, right?
Yeah, from Austria, enjoying the last few days of warmth in this October. It's pretty good.
Yeah, very good. So, and Mark, would you like to give an introduction about yourself?
Yeah, sure. I'm Mark. That's probably obvious. I'm working here on the Spring Data team since 8 years now, and by now I am leading the Spring Data project, meaning that I'm the guy pressing on the release button typically, while Christoph and others get to work on a lot of stuff that is pretty interesting, and I am keeping householding and doing release planning. I'm talking a lot with the various stakeholders of technologies. And I'm really honored to be part of the Spring Data team and have such great colleagues as Christoph.
Nice, very
Thank
good.
you, Bar.
And you, Chris?
Yeah, I'm Chris. Been working on the data team for almost 11 years right now. Started out with back in the days Spring Data for Apache Solar, and then started once I joined Pivotal. I basically started working on Spring Data MongoDB and Spring Data Redis. And during my work on Spring Data Redis, I got to know Mark, who was back in the days maintaining the Redis driver, one of the Redis drivers, and that's how we got in contact.
Yeah, and it's funny because I've been working with Spring and Java for more than a decade, and now I'm talking to you guys. So it's a pleasure for me and for our audience also. So drop your comments there, guys. So Mark, can you start by giving us an overview of what is Spring Data is?
Yeah, sure. So maybe let's take even a step further back. Spring is with us now almost for 25 years. I think the first release was in 2001 with the idea of giving developers back their productivity. So back then, it was the time where folks have been working with enterprise Java beans. You know, everything was XML, everything was pretty verbose, and developers were um, occupied at, at the same time with doing all the infrastructure fiddling. Um, and the other part of that time, they were able to implement meaningful business features. And Spring took a deep look on those things and said, look, while everybody is occupied with solving the very same problems and has only very little time to address the real business needs, let's do something about that. And They introduced a lot of abstractions. So maybe JDBC template is something that rings a bell, that makes you much more productive instead of tracking connections, closing the result set, dealing with SQL exception and these kind of things. And the very same is true for a lot of other components in the Java Enterprise ecosystem, like with JMS, so the messaging component, or EJBs. Now, with that stage being said, at some point, NoSQL databases entered the stage, and while every single database is different, they have quite a few things in common. So you can store data in there, you can query data, you can do updates and these kind of things, right? And we took the idea of giving back developer productivity pretty seriously by introducing a consistent programming model that is oriented and pretty much gravitating around the idea of domain-driven design that helps you to tackle application complexity, meaning that there is a common abstraction like repositories that help you to interact with your data regardless the underlying technology. So may it be a SQL database, may it be a key value store, may it be a document database. For all those cases, you have a pretty consistent programming experience where you can obtain data, save, update, so CRUD operations basically, with different stores implementing that technology. So while the technology under the hood may be very different and it can give you very different guarantees, and that is also a key part to remember, you don't have to relearn persistence technology across different databases. And I've prepared, a couple of slides to illustrate what I'm trying to explain here. So on this slide, you see at the very top the repository interface, and this is a typical entry point for a Spring Data user that you can interact with. But the repository is not the full truth. There is a lot more inside of this stack. If you have a repository-centric approach, then somebody needs to implement the repository. And from a user side, you simply declare a CRUD repository with your query methods, tell the database framework what domain time you are using, and which identifier type you're using. And beneath the surface, Spring Data is giving you a default implementation of that interface. So you don't need to do all that heavy lifting on your own, but rather you get an opinionated approach that you can leverage to interact with your data. This is clearly a very domain-centric and high-level abstraction that allows you a certain way to interact with your data. If you then have still the requirement to control, override certain functionality, so opinions that we made, assumptions that we made, then there is a whole different stack below that surface that allows you to take control over concerns like individual store capabilities, how domain objects are mapped into your database. And this really varies across all the databases. And also the functionality varies across all the databases, meaning that Spring is not trying to take away something from you and hide something from you, but instead the exact opposite is true. You can interact with the database native API if you want to, but without making up your entire mind about resource management, error handling, these kind of cases. Spring builds on top of the database specific API to expose the functionality that is under the hood of the database. So in case of MongoDB, we build on top of the Mongo client. We interact with Mongo database and Mongo collection, which are driver types. And all this is being provided to our template API. So the template API is a central abstraction class that basically mirrors all your database functionality. You don't have to search around all the driver. to find a particular functionality, but rather the template API is your entry point for a little bit lower level perspective on database functionality. From
Yeah,
there
and
on,
when you need to run complex queries, for example, it's better to use Mongo client, right?
Totally. So, for instance, a difference is the repository interface has this save method, where the repository itself tries to determine whether the object is considered to be new or existing in the database. So this is something that comes out of the object. On the template API, you have various insert methods, update methods, find and modify, find and replace, the typical MongoDB API. And the repository implementation itself makes use of that template API to then call and route calls into the database. Clearly, we have a mapping and conversion layer that takes a convention over configuration approach to map your data into your database. If you want to take control over how the data should be mapped, um, and that deviates from the recommendation that we make, you can use annotations, or you can even provide your own converters, much simpler than the codec API, for instance, that is being provided by the driver. And that is basically the thing that I mean with giving developers back their productivity. They have all the same concerns regarding database functionality, but they don't need to worry about how to get my resources, how to configure my resources. For instance, in the Spring world, if you consume the Spring framework or Spring Data, then typically you do that by leveraging Spring Boot. And Spring Boot is going to provide you with a configuration infrastructure and pre-opinionated pieces, how to wire all those database drivers into your application. Right. So I've been talking about the repository quite a bit, and the anatomy of such a repository is that you have to specify your domain type and your identifier type. So in this case, we have a repository for employees. The identifier type is a string. Internally, we map strings to object IDs. I'm still not convinced whether this is a great idea or not. Probably Christoph is going to acknowledge that as well. Sometimes, if you make certain assumptions, you only learn over time whether they have proven good or bad. But this is just something that we occasionally see. And what we recommend with when declaring a repository is to start out really small. So you can choose across a couple of base repositories from Spring Data that are being shipped by Spring Data. So we have the plain repository interface that is merely a marker interface. We have a CRUD repository interface that ships with methods for create, update, read, and delete. So for instance, count, find by ID. We have a further extension that is a paging and sorting repository for applying pagination. And this gives you a pretty decent set of commonly used methods. Still, we recommend starting out small because, the thing is, the more methods you expose to your application, the more likely it is that somebody is going to use that, and maybe that isn't your intention in that place. You can always define those methods in your own repository that are also defined by like CRUD repository or the Query DSL repository. Or if you are convinced that extending from CRUD repository is the right thing, then you simply just do that. And by extending CRUD repository, you get a whole set of methods that provides you with a good foundation. Now, clearly, somebody needs to implement that. So we have behind the scenes a default implementation that makes certain assumptions. And Spring wouldn't be Spring if you wouldn't get a ton of customization hooks. So for instance, you can write your own query methods where we try to derive the actual query from your method name. We'll get to that in a second. If that isn't sufficient, you can define a MongoDB query, a string-based query. And if that still isn't sufficient, you can provide your own fragments that implement a particular method built either on top of the driver or on top of the Mongo template. So you as a developer get really a lot of options, and probably one of these options is going to work for your project.
Yeah,
Now,
and this find all that you mentioned before, it's important to mention that when we are looking for performance, we need to use that, and we can, of course, pass the page that we are starting to find, and not at all just call the find all method, right?
yeah, find all is one of those methods where we are still not sure whether that has been the best idea. Probably when starting out with a collection that holds 10 documents, this is probably fine. But if you have a distributed cluster, hundreds of nodes, terabytes of data, then find all isn't going to be your friend in production. It
Yes.
is going to create an incident. So with great power comes great responsibility, and use find all responsibly.
Yeah.
So talking about query derivation. Strength of Spring Data is that we try to make really a lot of sense from the methods that you are declaring, because that is effectively the thing that you're going to see when you're looking into your code, and maybe not necessarily at your interface declaration, but rather at places that are calling those methods. So we think that those methods should be as expressive as possible to tell your code what this method is going to do. Everybody can call a method foo, and you still don't have an idea what is happening here. But if you call your method find by first name, then the method is going to find documents by first name, right? So that's the general idea. You can have a lot of variations in the support that this query derivation is doing. So you can specify predicates on certain properties. You can specify how the matching is going to happen. So whether it's an equality match, like here, find name, uh, sorry, like find by first name is going to do the equality match. But you can also use modifiers like the like keyword, greater than, less than, is null, these kind of things. And the query derivation mechanism is going to translate that into a store native query that is going to use, for instance, regex when using the like operator. Greater than, less than are native operators that match for numbers. You can even go as far as specifying a default sort, like here we do order by age ascending. You could sort that also descending. You could add multiple sorting columns. You can even specify how many records should be, or how many documents should be returned by by naming the method find top 10, right?
Mhm.
And there's another dimension on the return times, right? So here right now we are running a collection query that should return multiple documents that are automatically mapped into the employee domain class. You could get a single document, you can get a page, you can even get a Java 8 stream that uses batching and the fetch size underneath to obtain data in chunks. So you have really a lot of flexibility in those query methods.
Yeah, when we execute this method, Spring will look into your collection employee and try to find a field name by a first name, right? And we'll do the
Exactly.
equality, and then we'll order by the age, which is another field on our collection MongoDB, right?
Exactly,
Nice.
exactly. So we really recommend mapping all the properties to your documents. Um, and then you have really full power over your entire data model. And to give you an idea over how those things are typically mapped, we have here an example of a manager and an employee class. On the left side, you see how the manager is being laid out. It has an identifier, it has a name, and it has a collection of employees, and the employee also has an identifier, first name, last name, the typical things. If you take that and translate a data model into BSON, in a BSON document, then you would end up with a naturally flowing document that mirrors what you have in your domain type. And the great thing about MongoDB in this case is with our idea of being domain-driven centric, a document basically resembles an aggregate, something that has a structure, that has even a graph-like structure, that is consistent on its own, because a document, if you save that, is written at once. Clearly, you have the chance to run update queries on individual fields. But when you are working with a WYSIWYG scheme that you get what you see, then persisting the object in its form is a perfect match for domain-driven design in that case. Now, if you want to apply customizations, like your collection isn't called manager, but you want to call it managers, well, then we have the annotation side to express your intent. So annotations aren't really for programming, but rather they are demarcations about your intent, how a component should treat these. And that is exactly how we leverage annotations on the persistence level, that you express names or certain behaviors that should be associated with an element. So for instance, on the Java class manager, we have that a document annotation specifying the managers collection. And then as soon as you use the manager class in Java, all the operations map to the managers with an S collection on your database.
Mark, regarding the indexed, the annotation, what are the common pitfalls that can occur with the index? Because when the application starts, this index is executed, right? But if we have billions and billions document on our database, the application will keep running, or it won't start because the index is running.
Yeah, this is again one of those things that look pretty innocent, but in production they can create quite some trouble. We made a deliberate balance with this index annotation to get started quickly. So if you are developing an application in a rapid style and you want to iterate quickly without really including a lot of operational folks, then Spring Data provides you with this index annotation and a couple more annotations that will trigger index creation on application startup. And for development time, this is a super cool feature. Yet over time, we had also to realize that the same, what you mentioned is true, that if you have a huge database and then you suddenly run an index creation, that this can harm performance in the best case, or bring everything to a halt in the worst case. And so we decided in, I think, our last major version to deprecate the index annotation and to not automatically create all the indexes, but rather default to don't create the indexes on application startup to prevent those kinds of surprises. Still, if you find that this functionality is useful for you or a particular environment that you deploy your application to, you can still enable it through a Spring Boot property. Does that make sense?
Yes. Thank you for the clarification.
So we have tons of annotations that you can use if you find they're useful. In sharded environments, you can specify shard keys. You can rename certain fields if your database field name is different from your domain model. You can use optimistic locking with the advertent annotation. You can opt into auditing, so storing the created and last modified date, and or even who has updated and created a particular object. We support field encryption on the client side if you want to store sensitive data in your database, and then all the data at rest will be encrypted. We have support for good old dbrefs, but also in a graph lookup manner. We've introduced recently an annotation that is called add document reference to simplify references and manage them as you would do in a SQL database without the dbref ceremony. Now, you see, we get more and more into options that allow you to customize how Spring Data is working. Not only you can have query derivation for selecting data, but you can have also query derivation for deleting data, like delete by last name. That can make sense. We have support for geo functionality to look up data with a geo near a point or within a circle. You can specify read preferences. You can specify query hints. You can specify your own MongoDB queries if you want to customize that, or even go towards aggregations. And I think specifying aggregation pipelines is one of the better ideas that we have had in the past. And Christoph actually came up with that idea. Like, wouldn't it be cool to specify an aggregation pipeline in the repository? And yeah, that's where we are today. And I think Christoph can now talk a little bit more about aggregations because that's his area of expertise.
One last question for you, Mark. In terms of performance, can we measure which one is faster between Mongo template and repository?
Yeah, so the fastest option is always the driver. There's no doubt about that. Every bit of layer that you add will require a bit of performance penalty. And you need to be wary about what you're trading for that. So you're trading developer productivity for a few percent points of performance, which is due to a little bit of reflection to construct objects, reflective mapping, because we don't have one mapper strategy for all the objects, but each document is being mapped at the time where it is being loaded. So you can always estimate that like 10 to 15% of performance overhead is in when you are using Spring Data.
Okay, thank you. And Chris, welcome.
Thank you. Right. So Mark already set the stage for the aggregations as far as I can tell. So since vector search is kind of the new kid in town and everybody's talking about vector search and the aggregation stages and how to include vector search in your applications, to just put it into a RAG pipeline or stuff like that. Let's explore how we could use leverage the aggregation annotation to bring in vector search functionality into an application. So what you see here is basically what Mark already explained. It's a repository. We're talking about movies here, which is kind of related to the sample that you can run when you download the or when you basically are using the movie sample data set on MongoDB Atlas. So you can basically import that one into Atlas, and then you get a full-blown movie database. I extracted just a few of those movies, around 400 for this demo. And so we're having a movie repository right here. So we have reduced a little bit for the size. We have an ID, a title, and the plot, and of course, the data has the vector embeddings already within the document. So we're gonna load our data, preload our database with the movies that have the embeddings already in there. And now we want to do some vector search on the movies, like semantic search. So what we could do is, like we saw before, we could create a method that is called vector search. It basically takes the arguments. So you need the index, you need a path to the field that you want to search, and you gotta pass in the vectors for the database. Of course, up front, we have to set up the vector index on Atlas so that the database already does the magic for us. We're using I think it was a cosine index in this case. And then we can use something that is, we can make use of the parameter binding that we support with the aggregations as well as with the query annotations. So you can basically put in those marks here, and then and those will map to the indexes of your parameters, right? And then you can just go ahead and execute the query, pass in, like we do here in the test. You can use it. So you see the repository. We're using the plot vector index on the path for the plot and for the embeddings, and we pass in a bunch of vectors that you can see down there. Please don't look at those, because typically your model would generate the vector for you, and then you just pass it on, right? And so once we run this test, which may take a while since we're running, we're spinning up a local Docker Atlas container, preloading it with the 400 movies, and then just running the query there. And if everything goes the way we planned, then you see we created 420 movies, creating the vector index. That always takes a little bit of time if you're doing it for the first time, depending on the amount of data that you have in there. And then once we run this query, we should see some result down here on the movie repository. We just print out the result. So it's pretty easy to bring in vector search capabilities into an existing repository that you might want to have. For the records, I'm just using CRUD repository here because I've been too lazy to just declare all the methods that I need for the test. Typically, you'd go for just repository, or even if you don't want to buy into the Spring Data terminology, you could just repository. You could just annotate it and then just drop that part here. That would also work, but yeah, I'm not gonna do that right now. So just so you know. All right, if you're having more of those aggregations and vector research stuff, and you don't want to find yourself repeat this part over and over again, or even adding the projection afterwards, because you just don't want to load the vector embeddings, right? You don't want to load the entire array of vectors in the results set. So you'd add a projection stage and just exclude it from there. You can also create your very own annotation out of an existing one. So this is called a composed annotation. And sorry. And that would go as follows. You just copy over what you have already here, right? The very same with the placeholders, and just put it on to your very own annotation. You can name it whatever you like. You just have to annotate it correctly. And then you can just go ahead and call it vector search over here. And it will do the exact same thing as if you'd just written the aggregation. But this is a neat way to just don't have to repeat yourself. You can, it's more expressive, because then you already see this is meant to be a vector search if you cannot tell from the method name, right?
Yeah.
Those kind of things.
Yeah, and also you can create for not only for those dollar vector search, but also for all those stages coming from MongoDB, right?
Right. So you could use the text search if you're using the text search stuff on Atlas, that works for pretty much everything. It also works for queries. Like you can have the add query annotation, right? And then you just pipe in whatever equality query you want to have, and then you can do the very same thing if you want to with the binding. So this is a very, very straightforward way of bringing vector search capabilities to your repository. Still, you may want to have more control over how the things are handled internally. Like maybe you just don't want to put in the vectors, but hide that functionality and just put in, let's say, a string, and that internally then gets processed by the model, and then you run the vector searches. Things like those. For those cases, an aggregation approach using the annotation would work, right? So we need a more sophisticated approach to get this kind of thing done. All right, so let me show you how you could. This is just one way of doing it. Since Spring Data has been built with extensibility in mind, what you can do is you can always come up with bring in your own application code, right? So what you need to do for this is you can create something let's call it an Atlas repository, right? And then define the method that you want to expose in there, like a CRUD repository that has predefined methods, right? And then with the default implementation, you can do the very same thing on your own. You create an Atlas repository that has vector search. It could also have the text search in there. No problem. You just need to implement it later on. So you define the method in the interface, and you need to, of course, there needs to be an implementation. So if there is no implementation, Spring Data would see the method declaration and say, well, there is no implementation for it, so let's try to derive the query from the method name, which obviously doesn't work because vector search doesn't follow the pattern that we explained before. So we need to implement this, and this is just let's call this a repository fragment. It implements the Atlas repository. It's using the Mongo operations, which is just the interface to what Mark explained the template before. So the template is basically the implementation of the operations, and we're just using the interface here. So we get the Mongo operations, the template API that has all those low-level functions, but still maintains the resource handling and all that stuff. And then we implement the vector search the way we would like it to be, right? So we create the vector search document down here where we just append the required parameters and then build up. So we're pretty free in how we do this in here. We also could just parse any things. We could also bring in the model, right? So this is really, we're open what we want to do here. As long as it's in the context and you can set it up, you're good. All right. And since we want to use this functionality not only in one repository, but potentially in dozens of other repositories throughout our company. So we don't want to just search for movies, but we want to search for what has been before, employees or managers or stuff like that. We can use something like the repository method context. This is something that we just recently introduced, and that context gives you access to the repository the fragment is used in, right? So you get access to the metadata. You can ask the repository method context, which is the domain type of the current repository, so that you know, oh, we're talking about movies right now. And because you know that there is a document annotation, it can also tell you need to go to the movies collection, right? That's how it works. Of course, the repository method context and all the metadata doesn't come for free, but you have to tell it. So there's a repository metadata access interface that just is a hint for us as the infrastructure that you want to access the the method context and repository context, and then we just make sure that it's available for you down here. And then you can go on, create your vector search, extract the domain model, right? So we see the domain type, which would then resolve to a movie. And then we create our aggregation pipeline with the vector search operator, and then just go to the Mongo operations and call the aggregation with all the domain type mapping that needs to be done. And that's pretty much it. With that, all we now have to do is go back to our movie repository. Where is it? Here we have it. And just add the Atlas repository for movie. And since we declared already the vector search annotation, our test will just produce the very same result if I just run it again. It just now goes through the implementation that we provided up front and then just do the search. Again, this takes a little because we're building up the index again. You've seen this before. And then hang in there with me. There we go. It's basically the very same result. We get back our movies like we wanted to do. And the thing, one more thing that we introduced or are going to introduce with the next release, which will be out very soon, is previously those extensions like the Atlas repository had to live within the same namespace as your own repository. So it would have been com example data MongoDB, but now you see right here, this lives in a different location. And this is just some lookup that we do internally. And so that the lookup works, because we're doing some package scanning for the fragments and the implementation, so we need to provide a little hint, and we do so like you see it's a different project even, and a different artifact. There is a thing called Spring Factories, which is a tiny file that lives in the meta-inf directory. And that one tells us, see there, if you encounter this Atlas repository, then please look for this implementation. That way we find out, all right, there is an interface, and the user wants us to use this very specific implementation for the methods there, and then we can set up the application context correctly, wire things together, put the proxy around it, and then just delegate whenever there is a call on the repository to your implementation. Right. I hope that wasn't too fast. But yeah, that's what I wanted to show for what we're currently doing and what we are bringing with the next release, and how you can leverage MongoDB's vector search capabilities throughout the Spring Data repositories in various ways.
Yeah, amazing. Thanks for sharing, Chris. Let's see in our audience if we have some questions regarding this topic. Let me check. Okay. Yes, we have one. Does dbref work with reactive MongoDB? Mark, do you want to get this one?
Yeah, sure. So the short answer is no, but still it does, which is a bit confusing at first. But let me give you a bit more detail. So usually, if you ask me some question, you typically don't get away with under 5 minutes of a response. So the thing is, dbrefs require database interaction for resolution, meaning that you have to go back to the database and resolve that dbref reference. In reactive, what we try to do is to keep I/O latency, I/O blocking at a very minimal amount to give your application the best scalability that you can get. So meaning that in reactive, doing less is more for your application. And we deliberately choose to not follow DB references, and the same is true for add document reference. Otherwise, we would have to go to the database quite a few times, and if you have a lot of DB references, that would require a couple of round trips. There are also lazy DB references that create proxies, and maybe if you are a Hibernate user and you have crossed the transactional boundary, you have seen that having an attached Hibernate session is going to terminate with an exception because there's no association to the Hibernate session anymore to be able to resolve a lazily defined relationship. And so we decided to not implement that feature and instead provide you with rather the capability of resolving those references on your own. Now the thing is, the way how Spring Data is built, it has this converter component only once, and that is where this "it still works" part comes in, because the way Spring Data is built, how it is built right now, in a Spring Boot arrangement, if you pull in both the reactive and the imperative driver, then the conversion infrastructure that does the lookup of DB references is being configured with a DB ref resolver that uses the synchronous, so the blocking driver. And you can have only a single converter component, meaning that if you go through the reactive route, DB ref references are still going to be resolved, but rather by accident, and the resolution is going to block your thread, which is less than ideal, but that is the full story to your answer. Let us know in the chat if that helps or if you have any follow-up questions.
Yeah, thank you, Mark. We have another question here about performance and using Spring and Mongo template. And we discussed it a little bit earlier about the Mongo database and define with pagination, right, Mark? And at this point, it's very important to understand that when we get all those results, we need to separate in limit, skip, and Spring provide us this pagination with Spring with repository .find all, and you can pass a page. And also, in terms of database and MongoDB, it's very important to consider to using index if you are trying to find a specific range of data, okay? So this answer is for Naga, okay?
Yeah.
Yeah.
Ricardo, I have a bit more details to that to share. So we just recently extended Spring Data with the concept of scrolling, where you can obtain windows of data. So there is the concept of pagination. There is also the concept of streaming. And slicing data up into windows is yet another mechanism that we thought would be useful. So window queries don't have this strong affiliation of pages. So when talking about pages, you rather think about an application like eBay or Google, where you have a number of pages and each page has the same number of results. And with Windows, we thought let's loosen up those constraints a bit. So that you can use good old offset limit based scrolling over data that always goes back to the database and requests a chunk of data. We added also the possibility of key set based scrolling. So this is maybe a lesser known concept. What key set based scrolling is, it is leveraging the index. So for instance, if you are sorting by first name and last name, we additionally use the identifier to determine where in the entire result set your query would be. And instead of asking the database to produce the entire result set, offset-based scrolling requires the database to compute all the results, and then it gives you only the chunk beginning with the offset and then cutting off at the limit. So, and the difference to key set based scrolling is that the database can leverage the index, and from the index, it immediately gets the range of data and it does not have to build up the entire result on the database side, but rather fetch only the relevant records and give you back the 10 or 20 documents that you are interested in. And then this will help you in certain arrangements, depending on how you have modeled your indices, your documents, and how your use case is looking. This can give you huge performance gains in comparison to limit offset-based pagination.
Thank you, Mark. More questions coming from our audience. Let's check. Yeah, can we still use vector search without Atlas repository using MongoDB locally? I'm not sure if you can do it. Do you know, Chris? Or it's only on Atlas?
Well, the community edition still doesn't include vector search capabilities, if you're targeting that question. It has been announced lately that it will hopefully land in the community edition starting next year, maybe. At least that's what was said at MongoDB Local London. If that helps, you can still use, if you're using the Atlas CLI, you can now also start up a local Atlas instance. And then, of course, you can use Mongo template directly, put in the aggregation stage, and do vector search locally for development on your machine. That works. So you don't have to go through the Docker container and that stuff.
Yeah, but consider to use Atlas Cloud. Free forever. Right, Chris?
Yes, definitely. Using it myself.
But talking about Atlas, I think the addition of the local Docker container for local test containers testing is a pretty decent extension. And sometimes CI systems are air-gapped, making it next to impossible to reach out into the cloud. And for the development use case, this is a really decent addition that aligns with the goals of Spring, giving back developer productivity. So this is really a cool move.
Yeah, absolutely. All right, we are coming to the end of this live stream. Let's check more comments on the chat. And last words before we go, Mark, Chris.
Thanks for having us. Thanks for listening.
Thanks for having. Exactly. We didn't mention that Spring is an open source project, Apache 2 licensed. Maybe creating that kind of awareness. And that means that whenever you see a bug or a thing that you would like to contribute back, feel always free to reach out via GitHub to us. We are happy regarding every single bug report, every single contribution idea, happy to hear about your use cases, and also looking for how we can support your use case if that is something that is common across multiple users. And if you feel brave, even submit a pull request. We are happy to guide every newbie throughout the process of contributing. We share how we see things, and we are here to engage with you in discussions to make everything better and a better place.
Really appreciate it, Mark. Chris, want to share last words?
I said it before. Thanks for joining us today. Thank you, Ricardo, for being our host today. It was great.
Yeah.
With that, just go to start.spring.io, choose checkbox Spring Data MongoDB, connect to your Atlas cluster, and start using vector search. Shameless plug.
Mark, Chris, really appreciate it. Thank you very much. Thank you so much to everyone who joined us today. Okay, don't forget to check out YouTube channel and Developer Center for article, good contents there also. Okay, a big hug to you all, guys. Let's see you soon.
Take care. Bye-bye.
Bye-bye.
Bye.